and welcome to the VHDL Generics lecture. In this lecture, I'm going to explain what a VHDL generic is and how we can use them in our designs. A VHDL generic gives us a way of passing information into an entity externally. We know with an entity we have our inputs and our outputs. However, with a generic, you don't have to define it as an input or an output. You can think of a generic as a constant. However, you can apply it externally, which is a huge benefit in that it allows you to customize your designs in a way that you can just modify one line of code or essentially one value in your generic to change your design. Now, we'll be using these throughout our designs, as well as in the future, any designs you're working with, you'll most likely use generics. They're a very, very powerful tool in a way in letting you modify your design or define it in a way that's very easy to customize. So, for an example, let's take a look at let's take and generate a generic. So, if we want to have a design that is going to give us an AND gate, but we want 3 inputs and 3 inputs, so a total of 6 inputs on our AND gate. We want to have 2 signals, A and B, and we want them to be 3 inputs. So if we want to have 3 inputs for an A signal and 3 inputs for our B signal, and we want to combine all of these into an AND gate, which will give us a single output. So we'll take the top 3 and say these are an A signal, and the bottom 3 are a B signal, and we'll just have our C as our output. So in order to define this, we will first we want to make sure we have to define our generic in the entity. So we'll say entity, and we'll just give it a name. I'm going to call it example. Entity example, and then the keyword is, and then we want to use the generic. So the generic comes before the port, so we'll say entity example is generic, and we have to define the name. So we're going to give the name, we're just going to call it bits, so BITS, and then we do a semicolon, and we give it the data type. And we're going to call this one just an integer, so integer, and we have to give it a value, which is a semicolon equals. So in this case, we're going to give it the value of 3 because we're going to use this generic bits to define our A and B inputs. So we'll give it a value of 3, and then we close our parentheses, our open bracket, and then put a semicolon. Now we need to define the port. So we'll go ahead and use the keyword port and open bracket, and we know for our port we have A, we have B, and we have C. And our A is an input, so we give it the keyword in for the direction, because this is the port, not the generic, and we want to give it the data type, so we're going to say it's a standard logic vector. Now, what we want to do is, since it's a standard logic vector, this tells us we can give it any number of bits. So we want it to be 3 bits, however, we want those 3 bits to be defined by the generic. So we're going to say it is a standard logic vector that's bits minus 1 and the keyword down to 0. And we'll go ahead and put a semicolon. So what that's going to do is take our bits, which is 3 minus 1, so that gives us 2 down to 0. And that'll give us a width of 3. So for our A, we are going to have A0, A1, and A2. If we want to access each of these inputs individually, it would be like A0, so we'd have A0, A1, and A2. And on the same side, we would do the same thing for B. So we would have a B0, a B1, and a B2. And we're going to follow the same convention. We'll give our B, make it an input, and it'll be the standard logic vector. And we're going to make it the same width. So it's going to be bits minus 1 down to 0. and make the semicolon. Now our C is the output, and it's still going to be a 1-bit output, so we'll just give it the keyword out for the direction, and instead of a logic vector, it's just going to be a standard logic because it's a single bit. And then we'll close our bracket for our port and put the semicolon, and then to end our entity we have to do the end keyword, so we'll say end example. And now this defines the following AND gate where we have a total of 6 inputs, our A and B. Our A is 3 inputs and our B is 3 inputs. Now, if we wanted to, for say, make this a 4 input or a 5 input AND gate, instead of having to modify any other piece of code, all we have to do is change this generic value. So if we wanted to make this an 8 input total, a 4 on the A, 4 on the B, we would just change this generic value, what we call bits, and change it to a 4. So if we make that 4, it then becomes a standard logic vector of 4 minus 1, or 3, down to 0, which is a total of 4 bits. And so we can reference this bits throughout our design, example here being in our port to define the number of inputs we have, which is very powerful because otherwise if we wanted to modify this design, we would then have to go and come in the actual port and modify here where we say bits. We'd have it say 3 down to 0, or excuse me, 2 down to 0, and our B would say 2 down to 0. We'd have to modify that where it says 3 down to 0 and 3 down to 0. In this case, we'd have 2 different lines of code we'd have to modify versus 1. And what's more powerful is when we do things like component instantiations, we can pass this generic into our design, this bits, from a higher level design, and it trickles down so you don't even have to make any modifications to this specific design. And to finish this design, we'll go ahead and do the architecture quick. So we would just say it's the architecture, and then we give it a name. We'll just call it behave, and the keyword of, and we give it the name of our entity, which is example, and then the keyword is, and we have to do the begin, and now we define what we want the actual design to do. So we're just implementing an AND gate, so we would say the C receives a signal assignment of A and B. Now since A and B are both the same width, we can do this, and this will be fine because the number of bits we define, whatever number that is, A and B will both be the same size standard logic vectors, so that this signal assignment is valid and will work. And then we'll just do our end, and then we'll say our end of our keyword, which is our behave. That's our architecture, we've named it, and the semicolon. So that is an example of a design using a generic. And the key thing to note is that by just changing this one line, this generic value of 3, whatever you want it to be, you can change the input width of your A and B, and it makes it a lot easier. Now, in this case, it's a very simple design, but when you're working with complex designs that have lots of things going on, you may have more than just one generic. You may have 2, 3, 4, 5, however many generics you have, and you just change those 3, 4, or 5 values, and it changes the way your design is operating. Now, a lot of times the most common things you'll see in generics are, for example, like bits. If you're working with different designs, like for your bus width, for how many data bits you're sending back and forth, or like number of address bits, as well as like your clock rate or your intended output clock rate. So all kinds of things you can define in your generic, but it's a very powerful tool and something that you'll definitely be using a lot as you work through different designs in VHDL. So now what we'll want to do is open up your design, the button LED design, and in here we want to have a generic that we'll be using. The generic we're going to have is, we're going to tell it the number of buttons we have, because for every button we have, we're going to assume that we have an LED to correspond to that button. So as opposed to physically manually changing that, we're going to give it a generic. So in order to do that, we have to define the generic before we define our port. So we'll go, and where we have our port, we will use the keyword generic. And as we type that in, we can see that it highlights it because it recognizes it as a keyword. And we'll give it, open the bracket, and we'll tab and give the value. We're going to say num underscore buttons, and this is going to be used to define our number of buttons. And then we will, once we cover our data types, we'll see what data type we want to make our generic. But for this example, our number of buttons, we're going to give it an integer data type. So integer, and we're going to give it the initial value. In this case, I'm working with the RDA7. I have 4 buttons, so I'm going to give it the value of 4. I'll close that bracket and put a semicolon. So now the generic has been defined. I can now use this generic num buttons in my port as well as my architecture for this VHDL design. So anywhere I have num buttons, it'll be replaced with an integer value of 4. And that is the lecture on generics in VHDL.